I really love learning from the incidents that people have run into because it helps me ensure that my own systems and the ones of our customers become increasingly resilient. So let's talk about Toyota's 36-hour outage in August of this year. So let's break down what we know about them. They had a malfunction in their production ordering system that halted production on 28 assembly lines across 14 plants for 36 hours or 3 shifts. They describe it as having been due to the unavailability of some servers due to maintenance the prior day, where data in the database was deleted and reorganized and caused an error due to insufficient disk space. Oh my God, that's an expensive outage for given disk space. Then this also apparently caused a failure in backup, preventing a switchover and a suspension of domestic plant operations. And they were finally able to restore their system after the data was transferred to a server with larger capacity. So that's what we know. So what can we take away from this? One thing is that database failures have a very large blast radius. Databases are hard to manage, which tends to mean people try to have fewer but larger databases. And that means that they fail less often, but they have much more impact when they do fail. One of the most common issues we used to run into at AWS were with relational databases causing failures. I've learned over time to favor having a cell-based architecture where each cell can be managed, upgraded, and fail independently of any other cell. Now you can see, for example, that happens, how that works in networking, for example, cell towers for mobile systems. But I think it can equally well be applied to storage, to databases, to lots of things. Some people consider this wasteful. I personally consider it the slack that's necessary to build a resilient world because everything fails eventually. Now, obviously, I don't know whether this sort of approach would be reasonable for Toyota. I'm just trying to learn. Now, one thing I did find weird in this incident is that they required a successful backup in order to switch over. And that just doesn't make sense to me. You can't rely on the operability of a system that's failed to switch to its replacement. That's a complete anti-pattern. The system that's failed, you have to mistrust. It's gone. You need to fail over based on some recovery point objective, RPO, and recovery time objective, RTO, and just know that you have to deal with the inaccuracy, lost data, or whatever, through some sort of process management. And then you need to test it at least quarterly. And then obviously the smaller you can make the recovery point objective, the smaller the issue is because the fewer records that are going to be missynced. Now, backup restore is likely the wrong answer because that means intrinsically that you're going to be down for the period it takes to back up and then restore. And even if you have a consistent environment, it's consistent because everything's down in between. Now, also, if you have some sort of corruption due to a human error, dropping a table or a code error, databases are huge, so they also fail. A physical media backup probably won't work. So you do need some form of logical movement of data across systems with a short an RPO that as you can create and the ability to deal with inconsistency across systems. That's just the real world. What's the worst thing that could have happened if they had brought up a new system? They would have double ordered some extra parts. It's not such a big deal, not compared to having your plants down. So I think you really have to think about the cost of error versus the cost of not having resiliency.